Hi, my name is Jailton. I am a PhD student from Federal University of Minas Gerais, Brazil, and now I am going to present the research paper Why Modern Open Source Projects Fail. Nowadays, open source is widely used to reduce the costs or to speed up the software development. So, we can say that if software is eating the world, open source is eating software. So, most software produced nowadays depend on open source systems. And due to the appearance of the modern platforms for developing, like GitHub, open source systems are being created at speeds never seen before. For example, today GitHub has 64 millions of public and private repositories and 90 millions of users. Consequently, these projects are also failing at unprecedented rates. So, the main objective of our research was answering the question, why do open source projects fail? In this study, we addressed the following research questions. The research question number 1. Why do open source projects fail? The research question number 2. What is the importance of open source maintenance practices? The research question number 3. What is the impact of project failures? And the last research question, how do developers try to overcome the project's failure? To answer these research questions, first, we select the top 5,000 GitHub projects by stars to focus on highly popular projects, and we filter this initial list in 542 projects without commits in the last year, and we complement this selection with 76 projects declared as unmaintained in the project README by the owners. So we end up with a list of 618 open source projects. Now I'm going to show the results and the design to answer the research questions. To answer the first research question, why do open source projects fail? We conduct a survey with developers. In the case of individual accounts, we send the survey to the project owners, and in the case of organizational accounts, we send the survey to the principal contributor of the project. The survey questionnaire is composed by four open-ended questions. First, we ask to the subject if he agrees that the project is unmaintained, and if say yes, we ask why did you stop maintaining the project? Did you receive any funding to maintain the project? And do you have plans to reactivate the project? We sent a total of 408 emails and we received 118 answers. So we target a response rate of 29%. And we complement the survey answers with 36 answers from the project README. So in this case, we read the project README, looked for the reason because the project was abandoned. So 86% of the subjects agree that the project is unmaintained and 13% not agree. 15% of the subjects have plans to reactivate the project and 18% not have plans to reactivate the project. So, the main reason for developers to stop maintaining the project is because the project was usurped by competitors with 30 answers. For example, we have the following answer. The project no longer makes sense. Apple has built technical and legal alternatives which I believe are satisfactory. The second most reason for developers to stop maintaining the project is because the lack of time of the main contributor, with 27 answers. For example, we have I was the only maintainer and there was a lot of feature requests and I didn't have enough time. The third most reason for developers to stop maintaining the project is because the project is considered completed with 17 answers. It means that the project is stable and works as expected. And the project do not need change. For example, we have the following answer. Sometimes you build something and sometimes it's completed. Like if you build a building, at some point in time it's finished. It achieved its goals. So, combining the survey answers, we only consider that the project has failed when the project is unmaintained, the project is not considered completed by the owners, and the maintainers do not have plans to reactivate the project. So, we end up with a list of 104 projects that have failed. Now, it's important to show that our definition of failure it means that the project has been abandoned or deprecated. So, the project may have been important to the developers and users before being deprecated. So, from the final list of 104 projects, the most common reasons for the failure of the open source projects are usurped by competition with 27 projects. The project is functionally obsolete with 20 projects, followed by the lack of time of the main contributor with 82 projects, followed by the lack of interest with 82 projects, followed by the outdated technologies with 13, the low maintainability with 7 projects, conflicts among developers with 3, legal problems with 2, and acquisition when the project becomes private. Now I'm going to show the results and the design to answer the second such question. What is the importance of the following best of resource maintenance practices? To answer this such question, we selected 4 groups of 104 projects, among the top 5,200 projects. First, we created a group for the projects that have failed, and next we created a group for the top and a group for the bottom by the number of stars. And finally, we created a group of a random sample of 104 projects. So we analyzed the adoption of 80 open source maintenance practices. First, we analyzed the presence of a README file. Next, we analyzed the presence of a license file, the availability of a homepage to promote the project, the use of a continuous integration setting. In this case, we check the use of a thread CI. We analyze the presence of a specific file with guideline for the contributors, the presence of an issue template. Next, we analyze the presence of a file with a code of conduct. And finally, we analyze the presence of a pull request template. So, comparing the presence of a license file specifically, 61% for the failed project had a specific license file versus 88% for the top group. Analyze the use of a continuous integration. 27% of the projects that have failed use a continuous integration versus 68% for the top group. And finally, analyze the use of the contribute guidelines. Only 16% of the projects that have failed use a contribute guideline versus 72% for the top group, which is the most difference between these groups. Now I'm going to show the results and the design to answer the third research question. What is the impact of the project failure? To answer this research question, we count the number of open issues and pull requests for the group that has failed. We found over 4,700 open issues, and we found around 300 open pull requests. This graphic shows the distribution for the opened issues and the distribution for the opened pull requests. For the opened issues, the median measure 32, and for the opened pull requests, the median measure 4. Now I'm going to show the results and the design to answer the last research question. How do developers try to overcome the project failure? To answer this research question, we manually analyzed over 1,600 issues. We found in 32 issues, developers discuss about the project status. For example, we have the following titles of these issues. In this project dev, is project maintained, is developed of this ongoing. We found a total of three kinds of strategies that the developers try to overcome the project failure. First, we found that the developers try moving the account of the project to an organization account to share the responsibilities of the project. We found this kind of strategy in 5 projects. The other kind was include new core developers to the project. We found this kind of strategy in 5 projects. And the last strategy was transfer the project to new maintainers. We found this strategy in 3 projects. And finally, in 19 projects that we not consider as strategy because the owners suggest that the collaborators migrate to another project because they do not have plans to reactivate the project. So, finally, the takeaway message of this research is the top 5 most common reasons for the failure of open source systems are the project was usurped by competition, the project became functionally obsolete, the lack of time of the main contributor, followed by the lack of interest of the main contributor, and the project based on outdated technologies. And we compare the failed group versus the top project and show the difference between these groups in the use of contribute guidelines. So we show that the most difference between these groups is the use of contribute guidelines. The second most difference was the use of continuous integration that in this case we analyze the use of a Trav CI service. And the third most difference between these groups was the presence of a license file. Thank you for your attention.